The Occasional Podcast, Season 14, Episode 10. An interview with John Siau of Benchmark Media Systems.
Hey everybody, thank you so much for joining us. This is this is actually our second try at an interview with John Siau from Benchmark. We had him on the show once before, but we had our one and only terminal technical difficulty on that one. So I'm so glad to get him back on. It was a great interview, and now we're going to get it done. John, thanks for joining us. How are you?
Oh, you bet, Brian.
John has a lot of stuff going on. You've been in the industry. You've straddled both the pro side and the consumption side of things quite a bit. What kind of inspired you to first get into music in the first place? And do you come from like a pro background, or is it more technical? How'd you first get into audio?
The way I first got into audio, my dad was a ham radio guy, and he was a radio operator in the Second World War.
Wow.
Had all kinds of radio equipment. I grew up with this stuff, and so I was always collecting any kind of surplus electronic gear I could get my hands on. And you know, so when I was 7, 8, 9, 10, 12 years old, I was collecting old radio gear and putting things together. And I had an old shortwave radio receiver that my dad had picked up in Hawaii when he was in the war. And I used to enjoy listening to ham radio stations and also AM broadcasts on shortwave radio when I was a kid.
That's very interesting. My father was also a shortwave guy.
Oh, really? That's
yeah,
so
and
cool.
he had one growing up. It was so fascinating the way it all just worked so instantaneous, and it was so like anonymous. Right, you had to identify yourself with a call sign and all this, and it was also for him parlayed into trucking because truckers kind of have their own, or they used to have their own discrete channels to kind of chat on. So it's just very like one of those niche hobbies that exists that like I don't even think the general populace is really aware of it. Just like this one.
Well, and in those days, it was unique because you could talk to somebody on the other side of the world, and so we would sit there in the shack at late hours of the night talking to people in Russia, people in Poland, people in South America, and it's just very cool. Today we take it for granted that we can text people all over the world. We can FaceTime with people everywhere in the world. But it was in those days. It was ham radio was kind of a unique avenue to do that.
So that's like your early inspiration. What then kind of path did you choose into education from there?
So I went to Syracuse University, the engineering school at Syracuse University. I got involved with a band my freshman year. I had started out in mechanical and aerospace engineering, and once I got involved with the band, and I was really into HiFi from a young age, and so I immediately changed my major and got into electrical engineering because of my interest in audio. And so I mixed sound for this local band for most of the time that I was in college, and then took my first job in video at CBS Technology Center in Connecticut. I was part of CBS Television, and worked on HDTV back in 1980 to 85, and this is about 20 years before HDTV showed up in the showrooms.
You remember the like apocalyptic description of HDTV? There was like such a fervor of my TV's not going to work anymore. Do you remember that transition?
Yeah, everybody was worried about that.
Freaking out over that. Yeah.
And now we can't believe how bad old video looks. You see something that was recorded.
They always make it like smaller in the frame. Like we got to hide how pixelated it was. And there's even like these filters for like the 80s VHS look. Yeah. And that actually is quite nostalgic to me because I had a camcorder in college and the quality was just absolute garbage. It was like so bad, but it had like kind of its own filter you can copy, I guess. Now that's like pretty interesting.
This episode of the Occasional Podcast is brought to you by AudioQuest. All AudioQuest products, from the company's most modest parts to its most ambitious works of art, are thoughtfully designed to deliver outstanding performance and exceptional value, regardless of price. No matter how little or how much you invest, AudioQuest is made for you. Explore AudioQuest's award-winning cables, power products, and accessories at audioquest.com. Tired of audio reviews that sound like they were written by robots? Us too. For the last 15 years, Part-Time Audiophile has been an open revolt against boring. And this year, we're doubling down. We have a brand new look and a brand new name, but the same old attitude. Find us at pt.audio for all your turntable throwdowns and amplifier face-offs. Great sound meets good times at pt.audio.
One of the things in college is like every dorm room had a hi-fi system. You know, big speakers, amplifier, turntable. Every dorm room, you could go right down the hallway, and every one of them had a hi-fi system. And when I was in college, I used to go to the used room in the hi-fi store and buy this piece of used equipment and that piece of used equipment, whatever I could afford on my college budget, and put together a really nice hi-fi system to listen to. And so, you know, that was the days when you could go down the road and there were 5 hi-fi shops all next to each other in Syracuse, and now we don't have a single one.
For those listening who might want to be inspired to become an audio engineer, I've had several people on the podcast that talk about it's like a dying art. How do we educate people to go to make new hi-fi gear and possibly educate them on the discoveries we made on this thing? Because, you know, like cell phones have audio, but, you know, hi-fi can be a different animal in terms of its goals, right?
Yeah.
What do you make of the current state, and what was your experience? Because the main takeaway I get from a lot of these interviews is there is no audio design path for the most part. Is that correct?
Right. So it would be an electrical engineering degree or a computer engineering degree for all of the embedded systems that we have today. You know, the DSP, the user interface. There's a lot of things that go into a product besides just the audio path, but the audio path is best served by somebody with an electrical engineering degree.
When you found your way into audio, were you able to draw much from the idea of community as you moved into audio more? Because a lot of what the people say, like that I've interviewed from across the pond in Britain, were like, you know, we had all these great minds, and we would get together and have whatever, or there was some type of community where they were bouncing ideas back and forth amongst individuals to kind of generate a movement of sorts.
One example maybe is the benchmark AHB2. So we collaborated with THX, with a guy in England was one of the primary designers of the amplifier topology, actually, which is very unique with the feed-forward error correction system. We had a power supply designer in Canada that we worked with. We worked with some people out of California. We did a lot of the circuit design and all of the circuit board layout right in our place in Syracuse. And so it was this international collaboration to build this very special product, which is the AHB2 power amplifier. So it is the lowest distortion, lowest noise power power amplifier that's available at any price, and that was its claim to fame when it came out, and it still holds that top position, 135 dB signal-to-noise ratio. And so our goal when we design products is to keep the distortion and noise below the threshold of hearing, the 0 dB SPL level, at the listening position. And the entire benchmark audio chain can deliver that performance. And so then it comes down to how good are your speakers, how good is your room, and those become the focus points of improving your system.
So what do you kind of make of the modern situation in relation to measurements versus, actual listening? Because there's like kind of like competing camps. The way it's been explained to me is like a lot of people, they don't have the opportunity to listen, so they tend to lean harder on charts and graphs and specs to try to make their decisions because they don't have the opportunity. What do you kind of make of the modern atmosphere around measurements versus listening?
Well, the two go hand in hand, and I would say the vast majority of people that look at measurements don't understand what the measurements mean, and a lot of times the measurements aren't expressed in the right units in order to be able to even interpret what they mean. And so you can look at these THD curves from various amplifiers, and because they're plotted in terms of percent THD, which means nothing in the real world, it's very hard to look at those graphs and understand what they mean. And I've got an application note on my website that talks about this, and I've taken I took 6 or 7 power amplifier curves that were published in Stereophile magazine and replotted them in terms of sound pressure level. So what's the sound pressure level of the distortion and noise versus the listening sound pressure level? And that same data comes to life when you look at it that way. Measurements are important, but listening is the ultimate test, and the measurements are useful when you're designing a highly transparent product. So if you're designing it to be low distortion and low noise, the measurements are a very useful tool. If you're designing a product that's designed to add second harmonic distortion and add some coloration, the measurements are not very useful. So it all depends on what your product goals are. Am I trying to design a transparent product, or am I trying to design a product that has some coloration to it? And the one that has coloration is not going to look good on the measurements, but it's going to have a particular sound that you may be after. Now, we come from a pro background, and in a recording studio, it's very important to have a highly transparent signal path and monitoring system, because you need to know exactly what you're putting down in the recording. In the mastering room, you've got to know exactly what you're putting on that final recording that's going to go to the public. And if you've got a transparent system in your listening room, now you can experience the same thing that was experienced in the recording studio. And so it brings that recording studio experience, or that live venue experience, into your own living room. And so that's our approach. But there are people, and it's valid, there are people who like to have components that change the way the music sounds. And if that's your thing, benchmark is not the solution for you. But if you want a transparent and clear playback system, benchmark's the place to go.
Would you say that you lean towards the idea of this, the absolute sound? So is part of your goal to say, obviously, I have to state, it has to be unamplified, right? So there's a guitar playing here, and it's unamplified, and I'm trying to capture that sound and reproduce it on the other end. Is that part of your goals?
Well, that can be, if that's what the goal was of that particular recording. But my goal is to give you exactly what was created in the studio. So whatever was heard on the studio monitors, that's what I want to reproduce in the living room. And the only way to do that is with a highly transparent system.
An important but different caveat. It's not the instrument. You're saying, I want this to reproduce what was on the studio monitors.
Yeah.
In the studio.
I want to hear the same thing that was heard on those studio monitors. And the only way you're going to do that is with a transparent system.
Very interesting. Slight change. People don't usually put that together like that. I like that. Of all the specs that are used in marketing for high-end and just hi-fi audio equipment, which spec do you think is most often misrepresented?
Well, I think THD and THD plus noise are very misunderstood, and the biggest problem is that we've always plotted that in percent, and percent means nothing in the real world.
Can you explain why?
1% distortion when the signal level is very low is very different than 1% distortion when the signal level is very high. And what you have to look at is actually the amplitude of the distortion components. And are they above the threshold of hearing or below the threshold of hearing? If they're above the threshold of hearing, now we're relying on the music to mask the defects in the electronics. And I want to give you electronics that don't need to have the music hide their defects. So basically, I want to deliver the music without any electronic fingerprints and not rely on the music to mask the defects in my electronics.
I'm assuming you're familiar with the Harman curve and some of the research that Harman has done in terms of the frequency response. There have been quotes out there, I'm not sure to their validity, but they bounce around the idea that some people believe frequency response is the only thing that matters. If you don't have the frequency response, everything else is trash. And then, so Harman, presents this ideal. Maybe it's not this perfectly flat thing, but there's a preferential curve. How do you think about that, and how do you apply it to the gear you make?
You'll find that the frequency response can be very much a function of the room and so forth, but the electronics themselves should be delivering a perfectly flat frequency response, but it's important that it extend quite a bit below 20 hertz and quite a bit above 20 kilohertz. And the reason is we want to maintain accurate phase response over the frequency range of human hearing. So if you were to roll off at 20 hertz, for example, what that does is it delays the bass information. So your bass is coming late, and we're always struggling against late bass, and so we design our electronics to have a corner frequency of 0.1 hertz on the low end, and 200 to 500 kilohertz on the high end, and that keeps the high frequency phase response accurate, and it keeps it well matched between the left and right channel. And when it's not well matched between the left and right channel, what happens is your high frequencies jump out to the two speakers. And so you may have a drum kit right in the middle of the phantom center image, but all the high frequencies are coming out of the two speakers. And you've lost that focus over the entire spectrum. That whole drum kit should be right there in front of you, not spread out all over the room, unless it was actually mixed that way in the studio.
That's very interesting, because I've brought up this subject of 20 to 20 many times. I don't think anybody's ever brought that particular point up yet.
It's all about the phase response.
Yeah, phase response.
Yeah.
So it's not exactly the tangible of what we can hear, but its effect as it bleeds down into the rest of the spectrum.
When you set a roll-off point, say 20 kilohertz or something, you're impacting the phase at frequencies much lower than that. And so you need to keep those corner frequencies well out from the frequencies of interest.
One of the things that's coming up more and more, there is a little bit of a trend, there is a slight trend towards all-in-one speakers, where the amp is directly paired to a driver. This being the way it's proposed, the advantage is I have one amp made for one driver that we can find a perfect synergy with, as opposed to a speaker that may or may not be designed to work with a range of amplifiers. For you, the inverse, when you're making this amplifier, did you design it with a specific type of speaker in mind? And how, why do you make that bandwidth? You can't be a perfect match with every speaker out there. There's too much variety. When you design an amp, is it for a specific speaker you like, or how do you manage that width?
Yeah, so if the amplifier has a low output impedance, which shows up as a high damping factor, it will be agnostic to the pairing to various speakers, as long as the loading of the speakers is not causing distortion in the amplifier. And so one of the things about the AHB2 is that it can tolerate very difficult phase angles, very low impedances, and not have a rise in THD. So it's really designed to be agnostic to what kind of speaker you connect to it.
When you think about the quality of parts in an amplifier from your perspective, what do you think is some of the priorities people should have with amplifier parts? You need this particular part. If you skimp on this, it's done. Or, I really like an expensive case. How much?
So I would say don't get overly focused on the parts themselves. We use metal film resistors, and those are necessary in the audio path. But what's more important is what values are we choosing. It's all about the choices that the designer has made, and less about the type of components, but how those components are used has a much bigger impact than the brand or type of component. So it's the full understanding of that from a signal-to-noise ratio standpoint, a distortion standpoint. All of those factors come into play, and it's a lot less about the actual components themselves.
And akin to that, if we broaden it out just a little bit, we often talk about budgeting, what's the highest priority, speaker, amplifier, source, wire. And then, of course, the trick is always the room, right? When you look at that kind of equation, where do you pull priorities out in terms of components?
The most important thing is the room itself. That will have a tremendous impact on your listening experience. And the first most important audio component is the loudspeakers. And I don't sell loudspeakers, so that advice is coming.
That is saying something. I like that.
That's coming from somebody who doesn't sell loudspeakers, and nor do we sell room treatments. But room treatments are often the last thing people do, and it should be one of the first things they do. Treat the room, buy the best speakers you can afford. And they don't necessarily, the best ones are not always the most expensive ones, so beware of that. But invest in good speakers, and then the most important electronic component is actually the power amplifier, and then the second most important electronic component is often the preamplifier. The volume control system is often the weak point or the second weak point in the electronic chain. And then the D to A converter also needs to be addressed. And when you look at D to A converters, one of the things that to look for is a D to A converter with high headroom DSP processing or high headroom processing so that the intersample peaks don't get clipped in the interpolator. It's something that nobody is testing for, and it's really a big issue.
How much quality stock do you put into the programming bits of the DAC, the custom programming of the chip itself, and these things we call filters that are a stage? They can be custom, they can be off the shelf. How much power or influence do those stages have, in your opinion?
Okay, a lot of the chips that are available these days have got 5 or 6 different reconstruction filters that you can choose from. There's one filter that works, and the rest will change the shape of the audio waveform. And if you use a linear phase brick wall filter, I can cascade A to D, D to A, A to D, D to A, A to D, D to A, go through multiple generations, and what comes out at the end, the waveform will exactly match the waveform that goes in. If I choose any one of those other designer filters, the outcome at the end is vastly different than what went in. And so you'll find that benchmark converters give you one filter to choose from, and it's a linear phase brick wall low pass filter, and that will preserve the audio wave shape all the way through multiple generations of A to D and D to A conversions. And so people make a mistake of looking at signals on an oscilloscope and thinking that these filters are adding ringing and adding pre-ring, and they're not actually. That's exactly what you should be seeing when the signal is low passed. And that can be verified. And I did a video demonstration of that where we went through multiple generations of benchmark A to D and D to A conversion with no change in the wave shape. But then I inserted some D to A converters that had various different low pass filters, and the wave shape is vastly different coming out, and you can't go multiple generations and have it resemble the original at all.
In the course of doing this podcast, there's been a lot of talk about the evolution of digital audio, and specifically, as you've been saying, digital to analog conversion, which is what we're usually concerned with. Analog to digital is something they do in the Pro. You record it, you want to go to digital signal. But for the D to A, I think there's a lot of at least agreement that things were a little incorrect in some way when it first came out. The CD, in the 80s, the sound wasn't quite it is where it is here now.
Right.
Where do you feel like we are in the arc of D to A translation? Are we at the peak? Like, do we got it, or is there still a lot of room for growth in terms of your opinion of what needs to be done?
I would say there's one thing that's remaining, and this is something that probably plagues about 80% or maybe 90% of the D to A converters that are out there, and that's the inability to tolerate intersample peaks that exceed 0 dBFS. And it's very simply remedied by taking the signal level down 3 dB before it goes into the DAC chip itself. Or before it goes into any DSP processing that precedes the DAC. You've got to drop that signal level so that the intersample peaks, when they get reconstructed by the interpolator, don't get clipped off. And when the interpolator clips, it doesn't just flat top the signal, it spreads out in time and gives you bursts of high frequency noise. Is how I would describe those, that can happen many times a second sometimes, or you can have bursts of adjacent samples, every second or so with the beat of the music. And that's what gives a lot of DACs a digital sound. And when a D to A converter is properly constructed with the adequate headroom, we can build today wonderfully transparent A to D and D to A converters. And one demonstration we did in a studio in New York is we had, I think we had 16 A to D, D to A conversions strung together, and we had a group of mastering engineers in the room, and we were switching between first generation and 16th generation, and to see if anybody could hear the difference, and they were unable to tell the difference between the first generation and the 16th generation through the benchmark A to D and D to A converters. That's why we're used in a lot of recording studios. Abbey Road has a bunch of our D to A converters. I think they've got 51 of them or something like that.
A lot of audiophiles and even the designers and the people who consume this digital signal over time, since we started having the CD player burst back in the day, they've been looking for solves for the way it sounds, whether they're aware of a lot of the issues that are causing it or not. There was a rise of like the Delta Sigma DAC is evil, ladder DAC is a solution. What type of design do you favor? Do you kind of see any benefit to the way ladder DACs are done? And these other, and it's not just ladder DACs, because people say, I created this new thing, it's a DAC, it's not the Delta Sigma, it is this new thing that we've developed. All those solutions, what do you kind of say to that, and what do you make of them?
So the Delta Sigma or Sigma Delta is given a bad rap because of the intersample clipping problem. That's its downfall, because what these converters are doing is they're interpolating up to very high sample rates at 1 bit or a few bits, maybe 4 bits, maybe 5 bits, at a very, very high megahertz sample rate. And if they've got an intersample clipping problem, that's what gives them the harshness that people don't like. And that's why the ladder DACs have gained some popularity. So what you need is a Sigma Delta DAC with adequate headroom. And then you've got a very pure and transparent listening experience. The problem with the ladder DACs is linearity. The precision of the components is good enough to get barely 16-bit performance, and that's really the limits, physical limits of what we can do with even with very precise components, and you get temperature variations within the DAC that change the distortion. Lots of times in the ladder DACs, what they play some tricks. So they move the major transition where all the bits are flipping at once away from the zero transition. They'll offset it with a DC offset. So the worst distortion actually happens whenever you cross that point. So it doesn't happen at the zero crossing, it happens with a DC offset. So there's things that are done to make the specs look better on a ladder DAC than they look better than they really are. And of course they don't make much noise when they're idle, because there's nothing going on. So they often have a very good signal to noise ratio, but they have real distortion issues and intermod distortion issues in particular. And the best solution is a Sigma Delta DAC with adequate headroom.
There's WAV files, there's FLAC files, and then these 3 special letters that we've strung together that are not even like really talked about as much as they were, but I've seen it on T-shirts at the show. DSD. Do you take any advantage to having something in DSD? What's your take on it? Because you're talking about bits, and then this is traditionally known as like a 1 bit. 1 bit. The term flies around alongside with DSD, and that's somehow superior. Any opinion on that?
DSD is a terrible format for using in the studio. It's awfully difficult to work with. The quality degrades very quickly if you have to bounce generations. the DSP processing basically forces you to go into PCM to do any kind of processing. It's just a very unworkable system, and it's definitely inferior in terms of the signal to noise ratio of the transport system itself, and the bandwidth of it. There's a number of things that are vastly inferior to PCM, and we support DSD on our DACs just because people are interested in it, and we want to give you the ability to play both DSD and PCM, but if you have a choice of getting a particular recording in a PCM format or a DSD format, I would always select the PCM format. Now, having said that, there are some wonderful recordings that are available as DSD that are being recorded in DSD, and the thing that sets those apart is not the fact that they're recorded in DSD, but the fact that the people who are doing the recording are very, very focused on quality.
Right.
And so they're doing wonderful recording techniques. It's just unfortunate that they're also using DSD. But
I honestly, from doing this podcast, I feel like some of that particular point does also get lacquered on top of analog. Like, why does the analog sound better? Is it the analog, or is it the fact that people took so much time while keeping sound quality front of mind through the chain that ends up with the better result?
Yeah. There's Dave Brubeck has got a wonderful recording from 1959, and the recording's almost as old as I am, and I put that on every once in a while in our listening room, and I'm just blown away by how good that recording is, in spite of the time period that it was recorded. And I can put a lot of modern recordings on that aren't half as good as what they did in 1959. So, in some ways, we've lost ground, and we're rediscovering,
right.
Some of what they knew back then. But I believe that was a direct-to-disc recording. They had no ability to record the tape, and so all the musicians had to play it right, or play it the way they played it. That's what you got, and they went right through, and they might have lifted the cutter between tracks, but they basically laid that down and as virtually a live performance in the studio, and we've got just a wonderful recording available to us now. And the quality of recordings from the early '60s is much poorer than what was done then in 1959, because you've got the introduction of magnetic tape. And of course, early magnetic tape was not very good, and so you've got all the tape noise and the distortion from the tape, and so it's just really inspiring to go back and listen to this recording from 1959 that was so clean, yeah.
Do you think that this idea of quality through simplicity translates well to hi-fi? Some people who love like an integrated and a two-way speaker, less complex, just two speakers, one crossover, and then one amplifier that's an integrated. How do you see that kind of like peak up in other parts of audio when you think about designing stuff?
Integrated amplifiers, there may be a lot of compromises sometimes when you're jamming a preamplifier into the same package with the power amplifier. Mm-hmm. Biggest issue there is magnetic interference. You've got a big power transformer in most power amplifiers, and now you're trying to put all the line level circuits very close to the power circuits, And now we get away with that in the AHB2 because when it's not an integrated amplifier, but the analog board, which is the analog, the amplifier board, is just 1.5 inches away from the power supply. But the power supply is a switch mode power supply that runs at very high frequencies, and so the transformers are very, very small. Instead of being larger than almost the size of a dinner plate or something.
Yeah.
We've got these little transformers that are the size of a pill bottle, and the magnetic fields are correspondingly smaller. And the reason the transformers are small is not because they're lower power, but because they're running at much higher frequencies. The higher the frequency, the smaller the transformer can be for a given amount of power. So at 60 hertz line frequency, the transformers have to be very large. If we go up to 500 kilohertz, we can make them smaller by the ratio of 60 hertz to 500 kilohertz. And so you end up with very small transformers and very small stray magnetic fields, and that's how we can build 135 dB signal to noise ratio with the power supply 1.5 inches away from the analog circuit board.
Yeah, I do think there is a trend towards a more compact kind of identity, at least for hi-fi. There's an acceptance of, all-in-one units, and then, of course, the naughty word that we don't talk about too much, but Class D. What is the class of the amplifier that you designed, and what are your thoughts on Class D in terms of its application where it is right now?
So our amplifier is a Class AB amplifier with bipolar transistors, and it's also got Class H tracking rails, which is an upper set of rails that allow the waveform. So we've got lower rails and upper rails, and a small signal stays within the lower rails, and then you switch to the upper rails for each of the peaks. And it's a linear transition. And normally you just have a push-pull centered around ground, pulling it negative, pulling it positive. But there's a second set of transistors above and below those that can pull against a higher voltage rail. What that gives us is almost the efficiency of a Class D, but in a analog amplifier. And what's different about our amplifier versus a Class D is you don't have the rise in distortion with audio frequency. So a lot of Class Ds may look really good at 1 kilohertz, but they have a significant rise in distortion as the audio frequency goes up. And they also have a rise in distortion as the amplitude goes up. And the AHB2 will keep the distortion and noise below the 0 dB SBL threshold of hearing at your listening position at all playback levels. So you'll never have any distortion that exceeds the threshold of hearing. So again, your music is not masking the distortion. It's just not audible to start with.
I mean, obviously with audiophiles, a fascination with Class A. Somehow, the way it sounds is superior. Is there a way that it performs technically, you think, before you get into the beat? Why all the
great
solves?
question.
Why all the solves outside of Class A?
Yeah. So the thing about Class A is you're trying to get rid of that zero crossing distortion, and it's very effective at doing that. The downfall of Class A is very low efficiency. So The AHB2 is all about addressing that zero crossing distortion, and we do it with feed-forward error correction. Feedback is nowhere near fast enough to take care of those zero crossing distortions, and so you often get a little bit of zero crossing distortion, and it really comes into play when you're down at that 1 watt level and down at the half watt level. You'll see that distortion with a lot of Class AB amplifiers, particularly as the bias drifts with temperature. And so the AHB2 is very stable as temperature changes, because we're getting rid of that zero crossing distortion with feed-forward error correction. We're taking it out completely. We're getting a 30 to 40 dB reduction in distortion as a result of that feed-forward error correction. And so it has much higher bandwidth than what a feedback system would have.
Yeah, can you tell me a little bit more about what a feedback system is, what its benefit is, and if you're kind of saying you don't use it at all, there's a zero feedback?
No, we use a combination of feedback and feed forward. So at the lower frequencies, there's more feedback than there is feed forward error correction. And as you go up in frequency, the feed forward error correction is very, very effective at the higher frequencies, where the feedback is starting to become less effective. And one of the things that does is it makes us very stable into capacitive loads. It makes us very stable at high frequencies. We've got 200 kilohertz analog bandwidth, and we're able to stay stable into all sorts of speaker loads because of the feed-forward error correction. And so feed-forward error correction, if you think about the cruise control on your car, okay, that's a feedback system. So as I approach a hill and I start to go up that hill, the car slows down a little bit. The cruise control senses that slowing down and accelerates the engine and tries to maintain a constant speed, but it'll always be a little lower than your set point. And then as I crest over the top of the hill, it will accelerate beyond my set point and then settle back down. Now, you, as the driver, can act as the feed-forward error correction, and you see that hill coming, and you can give it a little assist by stepping on the accelerator and keeping the speed constant as you go up the hill, and then letting off at the top. And so it's that combination of feedback and feed-forward that can come up with, that can provide a better solution than a pure feedback system.
And the main function of that is to lower distortion levels, or is there more to it than just distortion?
It's lowering distortion levels.
Yeah, that's the main function.
Yeah,
that's very interesting.
And it's a 30 to 40 decibel, which is huge, reduction in distortion.
Yeah, I always thought it was kind of amazing. Like, we loop it back on itself and distortion disappears. It's like a magic trick almost. Like, can you explain how it happens? Like, I don't know if it's too complicated, but
so in a feedback system, you're looking at the difference. Let's take the car analogy. You're looking at the difference of your set point. You set it at 60 miles per hour, and the system sees that you're going 58 miles per hour, so it applies a correction signal, and it takes a while for the car to respond to that correction signal, but then it, in a steady state situation, gets closer to that 60 mile per hour set point, but it'll always be a little bit less because that's what drives the system. It has to have some error to drive the system. And feed-forward error correction is different. It's looking at, okay, what's the difference between my set point and where I'm at right now, and let's add that difference right to the output. So we have in the AHB2 two entirely separate amplifiers. There's the main amplifier, and there's an auxiliary Class A amplifier that that is summed passively at the output. And so the correction signal is passively summed right at the output terminals of the amplifier. And both of those amplifiers are very high speed, but the correction amplifier only needs to be about a 1 watt amplifier. It's a very low power amplifier because you don't need a lot of correction power to completely cancel out the distortion.
Is there anything that you like to address or you think about when you're reading and seeing response from people, the market in general? Any other kind of like topics that often bubble to the surface that you'd like to talk about? Because I know you do some wonderful writing. I think you do have a newsletter as well, and you have these different topics that you're talking about. Based on those writings and your experience writing and the feedback you've gotten on those, what do you kind of think are like the top 1 or 2 points that you think are a hot button of discussion right now?
I would say that there's no correlation between the cost of an audio product and the performance a lot of times. And so there's this myth out there that we've got to spend $200,000 to get good sound, and there's some $200,000 systems that sound dreadful. And there's some lower cost systems that sound great. There's some plenty of lower cost systems that sound terrible. But there's no firm correlation between the cost and the audio experience.
Thank you so much for coming on the show. I appreciate you. Anything you want to say to the audience before we go our separate ways here?
Thank you very much. Enjoyed this.
My pleasure.
Yeah.
The Occasional Podcast is a production of the Part-Time Audiophile Network, which includes parttimeaudiophile.com, The Occasional Magazine, the PTA newsletter, and audiohead.com. You can stay in touch with us on Twitter, Facebook, Instagram, and YouTube. The Occasional Podcast is produced and hosted by Brian Hunter, executive produced by Scott Hall at PTA Productions. The Occasional Podcast and its original associated music is monitored, mixed, and mastered on the Focal Trio 6 BE studio monitors. AI songs produced by Udio.com. If you haven't already, please subscribe to The Occasional Podcast on iTunes, Google, Spotify, or wherever your favorite podcasts are downloaded.